Hi, Hassler here. I'm going to work through some of the 1.5 notes. We're going to be solving equations, but this time we're going to have variables on both sides of the equal bar. Okay, so remember, our goal is to isolate the variable, or another way to put that is to find the solution to the equation. Our job is to figure out what the variable, typically x, is equal to by running through these steps. And so I chose an example that will allow us to look at all of the steps in one example. Now remember, what we like to do first is we like to do the distributive property. And one thing that we have to remember is to watch our signs. And what I mean by that is that you need to pay attention to negatives times positives or negatives times negatives. All right, so in this case, I have to apply the distributive property by multiplying 3 times x and 3 times 4. When I do that, I get 3x plus 12. And then I'm going to rewrite everything else. Now, the other thing I like to do when I solve is I like to draw my line all the way down through my equal bar to maintain my, to balance my equation, to maintain equality on both sides as I work. All right, the next thing that I like to do then is combine like terms. If there are any terms on one side that I can put together. Remember, when I combine like terms, you focus on one side at a time. This is not where I'm using inverse operations. This is where I'm using the operations that I see on that side of the equal bar. So for example, on this left side here, these two constants can be combined. 12 minus 2 is 10. And then I'm going to rewrite my 3x. That was a positive 10, so I'm going to write plus 10. And 5x and 6 are not like terms, so I simply just rewrite them. Now here's the new step when it comes to having variables on both sides. My new step when I have variables on both sides is to eliminate the variable on one side of the equal sign. Now, I could also get rid of a constant like we've done before, but we're going to wait to do that. Because if I get rid of a variable on one of those sides, I'm going to get down to equations that we've been working with for the last week. So I'm going to do that. Now, I could get rid of this 3x by subtracting 3x on both sides of my equal bar. Okay. Or I could get rid of the 5x by subtracting 5x on each side of the equal bar. So I have some options, okay? I could get rid of this 5x by subtracting 5x on both sides of the equal bar. In either case, I'm eliminating one of those variable terms, and it does not matter which one you choose to eliminate, okay? I personally like to keep my variable on the left side of the equal bar. That means I'm going to get rid of the variable that's on the right side of the equal bar. And again, 5x minus 5x is 0. That's going to make that variable term go away. All I have left then is 6 on that right side of the equal bar. And on the other side, 3 minus 5 is negative 2x. And then I have a plus 10. And now I'm down to something that is pretty familiar. I have a constant, a coefficient with a variable, and that's equal to some number. And the step that we do next is eliminate that constant. I'm going to subtract 10 on both sides of the equal sign. I have a negative 2x equal to a negative 4. And then I'm going to eliminate the coefficient by dividing both sides by negative 2. I get x equals positive 2 as my final answer. Now I can always check my answer algebraically. And checking algebraically, remember, means that I would replace each x in my original equation with the answer that I got. And then I could type each side into my calculator separately and see if I get an equal number on each side. If I type the 3 times 2 plus 4 and then minus 2 into my calculator, I should get 16. And if I type 5 times 2 plus 6 into my calculator, I should get 16. But I want to show you how to do this on the Desmos graphing calculator. So I went to desmos.com. And when I go to desmos.com, I need to um, type into my calculator the left side, what's on the left side of that equal bar. And I'm just going to look at the original equation to type that in. The original equation was 3 parentheses x plus 4, and my parentheses minus 2. And I'm going to hit enter. And notice when I do that, this line appears. In the next line, I'm going to type in what was on the right side of the original equation. And that was 5x plus 6. And I'm going to hit enter. And then I'm going to come over to the screen and I'm going to use my keypad or my mouse pad, and I'm going to pull until I can find where the two lines intersect each other. And when I click on that point where they intersect, I notice that the x coordinate is 2. That's what I found x to be. I also realized that the y coordinate is 16, which is what I got when I plugged my answer of 2 back in on both sides of the equal bar. So again, confirmation that the x coordinate is 2. The solution to my equation is 2. Okay, so in class, we're going to have you guys go ahead and try problems 1 and 2. And I'm going to go ahead and skip to numbers 3 and 4. All right, so I'm going to go through the same process with you, applying all those steps. The first thing I'm going to do is draw my bar. I notice I have like terms that I can combine. I get 17 minus 5x equals, and over here I have like terms as well. So negative 2x, I apologize. There is a typo that needs to be undone. In this problem, there should be a 3, it should say 3x on your paper. There we go. And now that that says 3x, then the two terms that can get combined are actually the negative 2x and the 3x. And when I combine that negative 2x with that 3x, I'm going to get negative 5x. And then plus 2. Okay, so now that we fixed that, my next job is to eliminate a variable on one side. I'll just go ahead and eliminate this negative 5x by adding 5x on both sides. When I do that, negative 5x plus 5x is 0. That variable term goes away and I'm left with 17. On this side, negative 5x plus 5x is also 0. So that variable term goes away and I'm left with 2. And here's the thing, okay? I have no variable term left. And I have a false statement. 17 does not equal 2. When this happens, we say that my final answer is no solution. Or a 0 with a line through it. And this no solution occurs when you have same coefficients on your variables after simplifying by combining like terms, but different constants. So when you look right here, notice that I have negative 5 as my coefficient on both of the x's, but I have different constants. Because the coefficients are the same, when I go to eliminate a coefficient on one side, I also eliminate the coefficient and variable on the other side. All right, let's take a look at another scenario. Again, I like to draw my line, and there's nothing to combine or distribute on the left, but on the right-hand side, I technically have a -1 that I distribute to each term inside that group. I'm going to rewrite my -9. -1 times 3 is -3, and -1 times -4 is a positive 4x. Over here, I'm going to rewrite my 4x minus 12. All right, I have like terms that can get combined. I have a -9 and I have a -3. When I combine those, I get -12. So I have -12 plus 4x, and over here I have a 4x minus 12. All right, my next move is to eliminate a variable term. All right, so I'm going to subtract 4x and subtract 4x. And again, I notice that 4x minus 4x means the variable term goes away. I'm just left with -12, my constant. And on the other side, 4x minus 4x goes away, and I'm just left with my variable, or I'm sorry, my variable term goes away, and I'm just left with my constant. And so again, what ends up happening here is that I have no variable left. But this time, I get a true statement. And when that happens, where I get this true statement, I end up having infinite solutions. And that means that I could put in any number for x, any number at all, in any of those x's in that equation, and I will always get a statement that is true. Now this happens whenever, notice, I have the same coefficients and I have the same constants. Notice up here in my simplified form, I have positive 4x and positive 4x on each side of the equal bar, and I have a -12 and a -12 on each side of the equal bar. So notice the difference between these two problems. In this problem, I had the same coefficient but different constants. And in this problem, I had the same coefficient and the same constants. And because of that, I ended up with two very different answers. All right, your job is to complete the rest of this page by applying the skills that we talked about on the front side and by keeping in mind any of these special answers that you might get, no solution or infinite solutions. If you have any questions, let your teacher know.